So let's go ahead and program up an EPROM, get the bootloader into it, hopefully, and see if the ROM card works. So grab a 1702 here out of the box. These have all been erased. It goes into the socket. Make sure I got pin orientation correct. I do. Pin 1 to this side. And in playing with this programmer earlier, I've come to realize that talked about this in the previous video. This programmer programs 2 bytes at a time. It was designed for an alarm system, I believe. And in this case, it'll program address 0 from these switches, and then address 80 immediately after from these switches. And it'll program address 1 and 81, 2 and 82. So I have to enter the data 16 bits at a time. And so on the sheet here, I've laid this out to be with the upper switches on the upper row here and the lower switches on the lower. It also, if we're in read mode, if we step, the address up count is in decimal, not in hexaoctal, so I've written in the decimal positions here. So it's rather clumsy to use. It was meant for like I said, an alarm system. It wasn't meant for general EPROM programming like I'm doing with it. But it is an EPROM programmer for 1702s. So let's get it in write mode and input some data. C89A, 89ABC, 89A. So that's 01, 9A. The other thing is a 1702 erased is all zeros, and you program in ones, which is interesting. And let's load those 2 bytes. Then we move on to 06 FF, 06 FF, and we have FF 80. We have 89ABC 3. I have to still think about this for some stupid reason. 47. 89ABC 3, 4, 7. Let's load that. 03, 13, 03, 13. Load that. F8 and 2, 3. F8, 2, 3. Load that. 8, 9A. F and 0, 8, 9A, B, C, D. Yep. A, F, 0, D. 8, 9A, B, C, D. 3, C, 2. So D, 3. C2, load that. 08, 7, C, 08, 7, C, load that. C, D, 8, 9, A, B, C, D. So there's CD, FF, load that. 6, 3, E, B, so that should be 6, 3, E, 8, 9A, B, 8, 9A, B, load that, F, 8, 9A, B, C, D, let's see, 4, E, F, D, 4, E, load that. D, C, 8, 9A, B, so there's DB, 0, C, D, 8, 9A, B, 0, 8, 9A, B, C, load that. 0, 8, 2, 3, 0, 8, 2, 3, load that. E, 6, 9A, 9AB. Oh no, it should be an E. E6, AE, load that. We should be up to address 15, which is going to be a 08, 8, and a B1, 08, 9AB, 1. Load that. Let's go back to read mode and reset. And we've got that flaky LED here, but 01, 06. I'm just looking at the upper LEDs. FF, C3, 03, F8, AF, D3, 08, CD, 63, FD, DB, 08, E6, 08. Let's reset and go across the bottom row now. So we have CA, FF, 80, 47, 13, 23, 0, D. Yeah, there's a little bit of ghosting there, but that's a D. 0D. Oops, well, it doesn't do anything here. C2, 7C, FF, 898, yeah, EB, 4E, 0C, 23, AE, that should have been a B1, 89, oh, it is B1. It looks to me like we've got those first 32 bytes correct. Rather than plow through and program the rest of this, I'm going to go stick it in the ROM board. We'll see if we can read it on the Altair. So, progress. Pull the part out of the socket, which seems weird to me. There's no power switch on this thing. Even though there's a hole in the side, there's no provision for a switch there. And it says do not have a do not insert a ROM before plugging in the power. So, okay. Seems a little abusive to the 1702, but such is life. So, that said, let's move on downstairs. So we'll start out here with a quick look at the board. The wire wrapping I did earlier to enable this ROM and the FF00 address space was incorrect. I was on the wrong pin of the 7442. I caught that and corrected it. I've added the two 8T97s down here. So these two deal with getting the data back onto the bus. These two deal with buffering the incoming addresses. We talked about that in a previous video. So the card hopefully is active on the bus here. The EPROM's in the proper direction. The system's powered up. Let's get over here and get a look at the front panel. And let's see, I want to look at address FF00. Let's just reset the machine for good measure and do a read. That's a really good sign. So the data we found at address FF00 is a 01, and that's what we expected, and we should find then, if I examine next, a 06, an FF, a C3, 03, an F8, an AF, a D3, 08, a CD, 63, FD, DB, 08, E6, and 08. And if we now go to address FF80 and examine, we should find an FF here. And we didn't. Did I do something wrong? FF8 0. Why am I reading a C? Oh no, I'm reading this wrong. There should be a CA here, so that's correct. Okay, that helps. We'd find an FF, an 80, a 47, a 13, a 23, 0D, a C2, 7C, FF, EB, 4E, 0C, 23, and an AE. So that's pretty awesome. We're actually reading the EPROM. So this is a really good sign. So remember that we're using the front panel here, so the bus is very static. But it does say that I've got the bytes in the right locations in the EPROM, so the weirdness with the programmer doing 16 bits at a time is understood. We're getting the data on the bus, so the two 1897s that gate the data from the EPROM back onto the bus are working. The only cards in the machine are the CPU, the front panel interface, and the ROM card, and the CPU is just sitting here idle. You can reset the machine, and I don't expect this to actually do anything. F800. That's the first part of the bootloader. If I run it, I would expect it to crash. Just because the entire bootloader is not there. Stop. But if we go back and examine FF00, we see that 01, and we should be able to single step the processor. 06, FF, C3, 03, and this does a jump to F8. 03 right here, F8, 03, and since we don't have any ROM at F8, 03, we're reading FF. So shoot, I cannot make this bootloader work with just a single ROM. It needs the entire alt mon and ROM, or at least the least significant and most significant ROMs in the address space. So I would expect it to have crashed here, and it did. It's just now saying FF's on the bus. But that's still pretty cool. So, you know, the processor is being allowed to single step. And it seems to be reading the ROM. And I say that because when we get up here to the C3 instruction, let me reset again. Examine. So we've got a 01. 06, an FF, a C3. C3 is going to be a jump, and it's going to go to the address 03, F8, so, or F803. Remember, the byte order is swapped, and that is a jump. And the next single step should jump to that address. And it did, F803. The processor is actually executing code. So this does say the processor is seeing the EPROM, is getting the contents, and is executing that code. That's a really good sign here. And of course, now when I let it, the next instruction, it would execute in FF. But no, this is a really good sign. Every indication here is this ROM card is working. Appears to me the CPU is actually reading the data from it, which is a really good sign. Not much more I can do here till I get all the EPROMs programmed up and the rest of the card wired, but this is a good sanity check. So definitely progress. So I guess I'll wrap this up here, and I'll see you in the next video.